Welcome to August 3rd's LeetCode Challenge Subsets 2. Given an integer array nums that may contain duplicates, return all possible subsets, also known as a power set. The solution must not contain any duplicate subsets. Return the solution in any order. So we're given an integer array nums 1, 2, 2. We see how there's duplicates 2 here. We want to return the power set of nums. So power set is basically all the combinations and permutations of basically the subsets inside the nums. For instance, the empty subsets included. There's one for 2, there's one combination 1 and 2, there's the itself, right? The 1, 2, 2, and there's combinations of the two 2's together. And if it's 0, basically, if we go to example 2 here, if nums with an array of 0 only, then the power set would be 0 and empty. Our constraints, nums between 1 to 10, and then the nums index goes from -1 to -10 to 10. Alright, so there's various ways of doing this. I saw a couple of solutions that's dealing with bit masking, but a power set is one of the most kind of basic way of understanding something. If you were taking a combinatorics class, a power set is a set with all the permutations of the subset, right? In order to solve this, I'm probably going to use the Iterative combination function. So I'm first going to start off with defining the subset that we're going to return, or output, I should say. Call it output. And that's going to be our initial subset, right? All subsets in the power set always contains the empty, the null. Alright, so since we already have that, we're gonna create an iterator. So I'm gonna call this I equals to 1. It's not 0 because we already have the empty subset inside. We're starting at 1 because we already have something inside. So while I is less than or equal to the length of nums, what we're gonna do is we're gonna iterate through our elements. So I'm gonna call this elms, and that's gonna be combinations. So this is an iterative function, combinations of nums and I. So for j in elements, if we're gonna sort j, actually sorted j, not in our output, then what we're gonna do is we're gonna have our output append our sorted j. Output dot append sorted j. And then that's pretty much it. We just gotta increment our counter here, and then we want to return our output. Okay, let's see if this works. It looks similar-ish. Submit it to see. Okay, accepted. Awesome. So basically, we create an output with a null subset inside it. Iterate from 1 because we already have 1. We do a while loop here, a while loop iterator, and then we basically do the iterative combination. Then for each element and for each index in the element, what we do is if we sort the j in the element and it's not in the output, we just add it to the output and then continue, and then we increment it each time. And then we do it until basically the index or the counter is exits this while loop. That means we have all the possible power set inside our output, and then we return it. So time complexity is at most big O of n n times, let's see, n squared, because we do at most we have to iterate through n times, yeah, each element in nums, the length of nums. Then we have to go through each element inside the combinations of nums. Actually, is big of n log n? I know the power set has a specific time complexity with it when you're doing this type of function. Yeah, no, it's big of n times m, where m is basically the numbers of various combinations you can have inside of it. So let's just call it n. So big of n squared. Space complexity, we're just storing everything inside a list, an array. So it'll be big of n as well, or big of n for space complexity. All right, that's pretty much it. Have a great day, guys.